it's Actuary Dude over here looking at another exam question. So basically, what is meant by the no arbitrage assumption in financial mathematics? That's just saying that an investor is unable to earn a risk-free profit. So that's just right out of the textbook. That's all that it really means, and you can add whatever else you want to that. And now looking at some of the maths. So a 3-year forward contract is to be issued on a particular company share. So let's just take a look at what 3 years looks like. And that's where we are. The current market value of the share is £4.5. There's a dividend of 20 pence, which per share was just been paid. The parties on the contract assume that the future quarterly dividends is going to increase by 1% per quarter year compound for the first 2 years, and then 1.5% per quarter year compound for the final year. So over these 8 periods over here, we're going to be going up by 1% from that 0.2 over there, and then we're going to be going up another 1.5% in the last year of those 3 years, so the last 4 quarters. Okay, and then we're going to find out, assuming a risk-free force of interest, which is 0.05, and there's no arbitrage, which we know means you can't make a risk-free profit, what is the forward price at this point in time? Okay, so we've got to find that one out. So all we're going to do is we're going to say that the forward price being discounted back, so e to the negative 0.05 going back 3 years, is going to be equal to this amount here of 4.5, getting rid of all those payments that's happening over here, the present value of those payments. Because by this formula we're working out what the forward price is over here. Okay, so that is 4.5 minus. Now this is a bit complicated. It's worth remembering the formula that I showed when I did how to derive an annuity. Basically, what it's going to be doing is that an annuity formula, so say for example an is equal to v to the n plus 1 minus v all over v minus 1. Okay, and I'll show you why that's necessary, because what we're looking at over here is saying that we have, for the first quarter, we'll have 0.2, and that's going to be increasing by 1%, and then we're going to be discounting that back by 1 quarter. So that's the year divided by 4 is a quarter. And that there is just going to be to the power of 1. So that's v, that's like our discount bit. Then we're going to be getting again 0.2 times 1.01 e negative 0.05 divided by 4, and that's going to be going back 2 quarters. And we're going to be doing that again and again until we get up to 8. So what's an easier way than sitting there with the calculator trying to figure it out, because you've only got a certain amount of time? Well, if we just let this bit over here be equal to v, then what we can really write is we can take out the 0.2s and then just use this formula over here, because this is what it's going to come down to, where v is this bit, which will then be v to the 9, because that's 8 periods plus 1 minus v, all divided by v minus 1. And if this formula is bothering you, just watch one of my other videos. So that's that bit over there. We've worked out this bit, and now we have to minus our last part, which is this year over here. So what that is, it's going to be the exact same thing. We've got 4 quarters, so we're going to be doing our 0.2 times, and now it's going to be v to the 5 minus v minus 1. However, we can't just use that 0.2 there, because it's already accumulated over 2 years, going 1% per quarter. So that's going to be times 1.01 to the power of 8, and that's only going to give us the present value at this point in time. We need to discount it back 2 years. So then that's going to be equal to e negative 0.05, sorry, cut it off the screen, times 2. And now once we find that, basically we're then able to figure out what k is equal to over here. So let's use Excel to try to figure that one out, what k is going to be equal to. So getting started, let's just write down that we have 4.5, then we just need to look at this bit over here. So that's going to be equal to, well, let's do there's v1 and let's say there's v2. So this v1 is equal to 1.01 times the exponential of negative 0.05 divided by 4, and then the other one we had was 1.015 times the exponential of negative 0.05 divided by 4. So very close. Okay, so this first part is then equal to 0.2 times, and it was v to the power of 9 minus v divided by v minus 1. And that's that bit over there, so that's fine. And now let's look at this long part over here. So that's equal to 0.2 times, let's do this bit already. So that's our second v to the power of 5 minus v divided by v minus 1, which is that bit there. Then we're going to times that by 1%, going over 8 quarters. And then we're also going to be timesing that by, we're going to be discounting that back, so the exponential of negative 0.05 times 2. And that gives us our second term in there. So k, the present value of k, so k discounted back, is equal to 4.5 minus these two, okay, which is this. And now we just have to do is equal to just find k by itself, we're taking this right hand side and we're dividing it by this bit, or another way is just the exponential of positive 0.05 times 3. Now we have that k is equal to 2.47. So 2.47, we can write that down. That was a bit confusing, so if you do have any questions, please ask, but otherwise, thanks a lot for watching.